In this video, we'll be discussing about the continuity of a function. It is highly recommended that you watch the video prior to this on limits. Definition. What do we mean by saying a function is continuous at x equal to a? Well, the left-hand limit of the function at point a should be equal to the right-hand limit. It should be equal to f of a, which should be a finite quantity. We'll understand this definition using some examples. As you can see in example number 1, the left hand limit equals to right hand limit, but it's not itself equal to f of a. So it's not continuous. Here, right hand limit equals to f of a, but is not equal to the left hand limit, and hence it's not continuous. Here, left hand limit equals to right hand limit, but f of a itself does not exist. So it's not continuous. Left hand limit is not equal to right hand limit, and f of a does not exist. Left hand limit tends to positive infinity and right hand limit tends to negative infinity, and f of a does not exist. In example number 6, all the conditions are being satisfied. Left hand limit equals to right hand limit equals to f of a, and hence example number 6 is continuous. Also, by intuition we can see that the graph of a continuous function can be drawn without lifting the pen. Like, I can draw the example number 6 without lifting the pen, but I can't draw any of these 5 without lifting the pen. Also, we are going to talk about continuity of a function only in the domain of the function. We are not going to go outside the domain for discussing continuity. There are several types of discontinuity. Major two types, removable and non-removable. In removable, there are two, missing point and isolated. Missing point, the limit exists, but f of a does not exist, like this one. This. The limit is existing, but the f of a is not existing. Isolated point type. Limit exists, f of a exists, but they are not equal. First example. You can see limit exists, but also f of a also exists, but they are not equal. Then non-removable, there are three. One is finite type. Like the limit does not exist in this case. So example number 4, you can see LHL is not equal to RHL, but they exist and they are finite. Infinite type, at least one of LHL or RHL is positive infinity or negative infinity. Example number 5, both LHL is positive infinity and RHL is minus infinity, and hence it satisfies the criteria. An oscillating type, example for this is sine 1 by x. The limit oscillates between two finite quantities. Now we are going to discuss what is continuity in an interval. To talk about continuity of a function in an interval close brackets a to b, what does this mean? That the interval is inclusive of a and b. So there are three conditions for this. That first, it should be continuous in a to b. Okay. Then second condition, the right hand limit of the function at a should be equal to the value of function at a, and it should be a finite quantity. Similarly, the left hand limit of the function at b should be equal to the value of function at b, should be a finite quantity.